Good evening, students. Am I audible? Can someone confirm if I'm audible? Why am I not able? Is anyone speaking? Can someone speak back, please?
Yes, sir, you are audible.
Good. Just give me a minute. Keep revising the concepts. So we'll get started. So the procedure is like yesterday only. I'll first explain the concept and then we can have a discussion session. Right here? Shall we get started?
Yes, sir.
Okay. So first we'll start with a discussion session. So first we'll start with a discussion session. So what were the topics that we discussed yesterday? So the one minute. There is a technical issue. 1 minute. Yeah. So what were the topics we were discussing yesterday? Can someone tell? So we were discussing about the specific heats of an ideal gas. Then we saw what is the molar specific heat at constant pressure and constant volume. Then we saw what is the relation between Cp and Cv. And lastly, we saw what is the work done in an isothermal process. That is the process of an isothermal expansion. Right? So is there any doubt from yesterday's discussion that you guys have? Is there any doubt from yesterday's discussion?
No, sir.
Sir,
Tell me.
sir, Cp minus Cv is equal to R, or Cp minus Cv is equal to R by J.
It is actually R by J, where the J is called as Joule's heat. But generally R, J, we don't use it. So you can take the Cp minus Cv is equal to R itself.
So when
Okay.
do we use R by J?
You will not use it, don't worry about it. We will use only Cp minus Cv is equal to R, that's it. Okay. So
Okay.
listen. Equation of an adiabatic change. So write down the next heading. Equation of an adiabatic change, which is also called as Poisson equation. That is, yesterday we saw what is the equation of a thermodynamic.
Okay, I found this on the web for yesterday.
PV is equal to constant, right? This is the equation for thermodynamic variable. In a similar way, there is something for an equation of adiabatic change that is going to happen, which we will try to derive. So we know that from the first law of thermodynamics, we have dq is equal to du plus dw, means the amount of heat that you supply will change the internal energy plus the work done, right? So let me take this as equation number 1. Now, we know that du is equal to Cv into dt. So yesterday I explained you Cv is equal to du divided by dt, right? So when you take Cv is equal to du divided by dt, then du will be equal to Cv into dt. Let this be equation number 2. In a similar way, we can say dw is equal to p into d into v, which I will call it as equation number 3. Now I will take this 2 and 3 and substitute it in 1. So dq will be equal to Cv into dt plus pdv. Okay. Now, since we are doing for an adiabatic change, for adiabatic process, I can say dq is equal to 0. So dq is equal to 0 implies 0 is equal to Cv into dt plus pdv. Okay. Now, let this be equation number 4. Now, we know that according to gas equation for 1 mole, if I consider a gas of 1 mole, which is generally taken as a standard value, I get PV is equal to R into T. Now, what we will do is we will differentiate on both sides. So when you differentiate both sides, right, it is written something like this. For this, you will apply the UV rule. UV rule, the product rule says f of x into g of x is something like this. F of x into g dash of x plus g of x into f dash of x, where dash represents the first derivative of that particular function. Similarly, I can write this as PdV plus VdP is equal to R is a constant. Derivative of t is going to give us dt. Okay. So from this, if you observe in this equation, I want to eliminate dt. So I will find dt in terms of other variables. Dt, I can write it as PdV plus VdP divided by R. Let me call this as equation number 5. Now what I will do is, using 5 in 4, what are we going to get? 0 is equal to Cv into dt. dt is PdV plus VdP divided by R plus PdV. Okay. So having said this, I'll take LCM. Cv into PdV plus Cv into VdP plus PR into PdV. This will be equal to 0. So what we can do here is, let me take this first. CV into VDP plus, I'll combine these two terms together. I will take that PDV outside. I will write it as CV plus R is equal to 0. Okay. But we know that CP minus CV is equal to R, which implies CP is equal to CV plus R. If that is the case, I will substitute it here. CV into VDP plus PDV into CP is equal to 0. So CV into VDP plus CP into PDV is equal to 0. Now, dividing both sides with CV into V into P. I'll divide it with CV multiplied with V multiplied with P on both sides. What will we get? We will get CV divided by CV into V into P. Sorry, CV into VDP divided by CV into VP plus PDV into CP, the whole divided by CV into V into P. This will be equal to 0. Now what we are going to get is CV into V and CV into V will get cancelled. Similarly, P and P will get cancelled. So what is that we are left out with? We will be left out with dP divided by P plus Cp by Cv into dV divided by V is equal to 0. So let me explain this. The reason why we did this is because we need to arrive at an equation like this, which is called as differential equation, which you will be learning in depth in your 12th math. Okay. So this Cp by Cv has an important relation. So Cp by Cv is nothing but the specific heats of gas, and it is represented by the symbol gamma, which is a very, very, very important relation in the case of kinetic theory of gases. Okay. So this gamma is an important parameter. Having this in mind, I can write dP by P plus gamma times dV by V is equal to 0. Now what I will do is I will take dP by P is equal to minus of gamma into dV divided by V. Okay. Now I will integrate on both the sides. So when I integrate it on both the sides, I get something like this. Integral of dP divided by P is equal to minus gamma into integral of dV divided by V. So integral of dP divided by P is ln P is equal to minus gamma into ln V plus, I will write it as some constant because here we are doing indefinite integration. I didn't take the limits. So it is my job to introduce a constant. So this is called as indefinite integration. Now what we can do is ln P, I'll bring this value to the other side, plus gamma times ln V is equal to C. Now this gamma will go this side as power. So ln P plus ln of V power gamma is equal to constant. So log A plus log P is log of AB is equal to constant. So when ln of PV power gamma is constant, then I can write PV power gamma itself is a constant. So this is the mathematical condition or equation of adiabatic change. There is the mathematical equation of an adiabatic change. When I say change, it can either be compression or expansion. In both the scenarios, you can use the same mathematical equation. That is what we mean. Is it clear, guys?
Sir,
So copy it. Tell me.
sir, the last step can you show? Sir, here how is ln T plus ln V power gamma it came, sir?
A log P is equal to log of B power A. Okay. You know this? If no, you can tell me a no.
Sir, can you repeat?
If you multiply log of anything with the value, then that value will become the power. That is log of x. Suppose you have b log x, then this is the same as log of x power b. You know this?
Okay, sir.
Okay.
Sir,
So basically, logarithms are the reverse.
Sir, you are not audible. Yes, sir.
yes, sir.
Yeah. Is it clear now? Is every step clear in this?
Sir, I have a doubt.
Please ask.
Could you show the slide, sir?
Yeah. Are you not able to see? I'm already sharing it.
No, sir.
Okay, just kidding. Screen sharing. Is it? I don't know. Screen sharing has failed to start. Now I guess I don't know what is the issue. Are you able to see, Subrajit?
No, sir.
It's not allowing me to share. I don't know why.
Sir,
Yeah, please tell me.
sir, you were explaining log of.
Yeah, I was explaining, but I'm not able to share my screen. 1 minute. I'll leave this meeting and I'll join back. Okay. Now I guess you guys should be able to see.
Yes, sir.
Tell me, which step do you want?
Sir, while integrating on both sides, integration of dp upon p, in that step, why don't we write a constant for dp upon p?
No, we can write C. Doesn't make sense. Because see, if you want to write, let's say you want to write ln p plus c is equal to minus gamma of ln b plus, let me call it as c2. The C1 will go to the other side. C2 minus C1 is some other constant. That's it. It's not a big deal. So we generally introduce a constant because there is a reason why when we do indefinite integration, there is a reason why we introduce a constant. Okay.
Understood.
Because integrate, I'll just tell you since you got this doubt. You know this y is equal to x square, right? So dy is equal to how much? Or dy by dx is equal to how much?
2x.
2x. Y is equal to x square plus 1. What is dy by dx? 2x.
2x, sir.
Y is equal to x square plus 100. Dy by dx is 2x. Okay. So when you want to integrate, you will take it to the other side. You will get dy is equal to 2x dx. Okay. Here you will get dy is equal to 2x dx. Here you will get dy is equal to 2x dx. Clear? When you integrate on both sides, what will happen? Y will be equal to x square. Y will be equal to x square. Y will be equal to x square. Correct? Are you able to understand? Yes or no?
Sir, it should be 2x square, right?
2x square divided by 2. 2 and 2 will get cancelled.
Okay, okay, got it, sir.
Got it? So all the three are x square only. Correct? But you got this dy is equal to integral of 2x dx. You got it from this question. Similarly, here this dy is equal to 2 times dx. You got it from this question. Means whenever you do indefinite integration, you should get back the question. That is the meaning of reverse operation of derivative. That's why integration is also called as antiderivative. Okay, but what is the mistake you are able to find here? Here y is equal to x square. I'm sure because I got back the question. But y is equal to x square is not the question here. Here it is x square plus 1. Here it is x square plus 2. Means if you integrate the same function by adding it, if you integrate the same function and you get an output, right? If you differentiate that output, you should get back the question. That's the meaning. Okay. So that is the reason why when you do indefinite integral, since you are not sure of what constant is added to that function, you add a c. That is why it is indefinite. Means you are not sure about it. Now you understand why we add c.
Yes,
Anyway,
sir.
these things you learn it in your math also, but just wanted to clear that out. Okay. Otherwise, ensure that you're thorough with this derivation. It's an important part. So if you guys are clear, I'll move on to the next step. Shall I proceed?
Yes, sir.
Okay. So I'll be making a note here. The next point is adiabatic relation between volume and temperature. Okay. So we know that PV power gamma is a constant. Similarly, for an ideal gas, I know PV is equal to nRT. If I consider 1 mole, I'll write PV is equal to R into T. So now we need a relation speaking about volume and temperature. They can be multiplied or whatever can be done. So I need to eliminate P. So P, I will write it as RT divided by V, and I'll substitute it here. So RT divided by V into V power gamma, I'll call it as a constant. So RT into V power gamma minus 1 is a constant. R is already a constant. So T multiplied with V power gamma minus 1, I can take it as a constant. So this is the mathematical relation between volume and temperature in an adiabatic condition. In a similar way, we can derive a relation between pressure and temperature also. That is called as adiabatic relation between pressure and temperature. So we know that PV is equal to RP, right? So V will be equal to RP divided by P. And we also know that PV power gamma is a constant. So P into V is RP by P to the power gamma is a constant. So I'll get P power 1 minus gamma into T power gamma is a constant. So this is another mathematical relation that speaks about the adiabatic relation between pressure and temperature. So the conclusion of the story is wherever you have adiabatic conditions, so wherever you have adiabatic condition, it will be something like this. P into V power gamma is constant. Then T into V power gamma minus 1 is a constant. P power 1 minus gamma into T power gamma is a constant. Okay, these are the three important relations which you need to use depending on what is asked in that particular problem. Yeah, now you can ask your doubts. Any doubts? Is the derivation clear?
Yes, sir.
Right. It's a simple thing, right? Now, shall I move on to the next one, guys? Any doubts? Everybody's clear?
Yes.
Okay. Now, what we will be deriving is work done in an adiabatic expansion. Work done in an adiabatic expansion. So we know the fact that dq is equal to du plus dw. So we also know that dq is equal to 0 for adiabatic process. When dq is equal to 0 for adiabatic process, I can say du is equal to minus of dw. So I can write dw is equal to minus du, which is equal to minus cv into dt. Right? So having this in mind, what we can do is I can write w is equal to integral of dw. That integral of dw I can write as integral of minus cv into dt from t1 to t2. So we know that cv is a constant. Minus cv into integral of dt from t1 to t2 is equal to something like this, minus cv into t2 minus t1. So from this I can write w is equal to cv multiplied with t1 minus t2. So this is one such expression. Okay. So this is one such expression. Have this in your mind. Now, the alternate relation that I'm going to explain now is, listen. We know that dw is equal to pdv. So dw is equal to p into d into v. And for adiabatic condition, P into V multiplied to the power of gamma is a constant. When that is going to be constant, I will write PV power gamma is equal to K. Then since I have dV here, I will write P in terms of V. I will write it as K divided by P is equal to K divided by V power gamma. I'll call this as equation number 1. Equation number 2. Using 2 in 1, what are we going to get? We'll get dW is equal to K divided by V power gamma into dV. Now integrate on both the sides from V1 to V2, which implies the total work done during this process is equal to K multiplied with integral of dV divided by V power gamma. Okay, this will be K into integral of V power minus gamma into dV from the same relation V1 to V2 only. So K into V power minus gamma's integral, I can write it as V power minus gamma plus 1 divided by minus gamma plus 1 from V1 to V2. So K divided by minus gamma plus 1 into, you need to substitute the upper limit. So V2 power minus gamma plus 1 minus V1 power minus gamma plus 1. Okay, so this I can write it as 1 divided by, observe, I wrote it as gamma minus 1, means I took this minus outside, then this will become minus. So K will get multiplied with each term. So I can write it as K into V1 power minus gamma plus 1 minus K into V2 power minus gamma plus 1. So what I did is I took the minus sign outside from here and the minus sign from the numerator also, so that they get cancelled, because it's a simple logic. I want things to be gamma minus 1, not 1 minus gamma, because gamma is equal to Cp by Cv. Yesterday's concept, we saw that Cp is always greater than Cv. So we saw that Cp is always greater than Cv, which means gamma is always greater than 1. So this will be 1 divided by gamma minus 1 into this K. See, what I'm going to do is I will write it as P1 into V1 to the power gamma into V1 multiplied by minus gamma plus 1 minus this K, I will write it as P2 V2 power gamma into V2 power minus gamma plus 1. So this will be 1 divided by gamma minus 1 into P1 V1 minus P2 V2. So this is the work done in an adiabatic process, and this can be taken as a second equation. Now, the third equation that I'm going to write is W is equal to 1 divided by gamma minus 1 into, I can write P1 V1 is equal to nRT1 minus P2 V2, I will write it as nRT2. This n, if I take it outside, then n into r divided by gamma minus 1 into T1 minus T2 is equal to W. This is a third expression that you can write. Okay. So this is the third expression. So all these are related to the work done in an adiabatic expansion or compression process.
Sir, could you show the slide?
I'll show it. You want to copy it or read it out?
I want a copy, sir.
From where should I show?
Sir, could you scroll down? Yes, sir, from here.
Okay. Write it down. Let me know once you're done.
Done, sir.
Done. Okay. So next. So next concept is work done in an isochoric process. So this is already known to us. We know that dW is equal to PdV, and this will be equal to 0 since dV is equal to 0. So if somebody asks you what is the work done in an isochoric process, the answer is going to be a 0. Similarly, what is the work done in an isobaric process? So when you talk about an isobaric process, dW will be equal to PdV. W will be integral of PdV from V1 to V2. This will come out. So P is constant, will come out. P into integral of dV from V1 to V2 is equal to P into V2 minus V1. So PV2 minus PV1 is going to be the work done for an isobaric process. This PV2 I can write it as nRT2 minus nRT1 when I consider it to be an ideal gas. If it is 1 mole, you know what you're supposed to do. And the last is work done in a cyclic process. So we know that from the first law of thermodynamics, dQ is equal to du plus dW. When generally what happens is in a cyclic process, a system returns to its initial state since internal energy is a state variable. So state variable means a variable that remains only on the initial and the final conditions. Since it is a state variable, then u is going to be constant and du will be equal to 0. When du is 0, in the case of cyclic process, you can conclude that the amount of heat that is supplied by you will get converted in the form of equivalent amount of work. Any doubts, guys? Any doubt? Is it clear?
Yes, sir.
Yes, sir.
No. Next heading is comparison of slopes of isothermal and adiabatic process. Okay. So slope is when you take a graph. Generally, you will consider a PV graph. So with respect to a PV graph, if you see for isothermal condition, what happens is PV will be equal to constant. So when you differentiate on both sides, we get PdV plus VdP is equal to 0, which implies PdV is equal to minus VdP, or dP divided by dV is equal to minus P divided by V, where dP by dV is what is called as the slope in, generally it is called as slope. Okay. So in this context, minus P by V is called as slope of an isotherm. Isotherm means the graph that you get. Okay. In a similar way, if you see what is an adiabatic process, what is it for an adiabatic process, then we can say P into V power gamma is constant, which implies on differentiating both sides, we get P into gamma into V power gamma minus 1 into dV plus V power gamma into dP is equal to 0, because I followed something called as chain rule. So P is a constant, derivative of V power gamma is gamma into V power gamma minus 1 into derivative of V is going to give you dV plus V power gamma into dP. This is equal to 0. Again, I'm going to collect the dP by dV terms. So I'll get minus gamma into P into V power gamma minus 1 into dV is equal to V power gamma into dP, which implies dP by dV is equal to minus gamma into P divided by V. So from, sorry, dP by dV. So this is the slope. This is the slope in an adiabatic process. So what happens here is slope in an adiabatic process is equal to, can I write it as gamma times slope in an isothermal process? So if they give you two graphs, whichever graph is going to be steep enough is said to be an adiabatic process, and whichever is not steep is what is called as an isothermal process.
Sir,
Tell me.
sir, in the chain rule, sir. Sir, it should be a differentiation of V power gamma, right?
Chain rule. Chain rule. Which one?
P into
Which
differentiation of.
This one?
Yes, sir.
P is constant. Into
Yes, sir.
derivative of V. So derivative of V power gamma is gamma into V power gamma minus 1. Correct?
Yes, sir.
Into, you should multiply. Sorry, you should differentiate B again. Because when I say differentiate on both sides, there are two types of differentiation. Okay. See, for example, y is equal to x square is there. If I say differentiate on both the sides, then dy will be equal to 2x into dx. Are you able to understand what I'm trying to say?
Yes,
If
sir.
I say differentiate on both sides, dy is equal to 2x into dx. If I say differentiate with respect to x, then dy by dx is equal to 2x. If you observe, they both are same. This dx goes to the other side. So that is what the chain rule speaks about. So v power gamma minus 1, no, this v I multiplied with, I differentiated again, so I wrote it as dv. This side it will be v power gamma into dv. I hope it is clear.
Yes, sir.
Right. Everybody is clear with this?
Yes, sir.
Okay. So that's it for today. There is one concept that is left out, that is the second law of thermodynamics, which are basic statement. Before that, you need to revise all these concepts. So those concepts I'll teach tomorrow, and I will start oscillations chapter. Okay, I told you, right? Oscillations and waves are more important. Kinetic theory, I'll deal with it at the end. Okay, guys. So any other doubt? So I suggest everybody to revise this chapter, practice all the derivations. Okay, we don't know what derivation is going to come and how many marks they are going to ask for. So it is better you have to keep it practiced. Okay. Any doubt, you reach out to me on the student support number. So that's it for today from my side, guys. Tomorrow, no this thing, no school for anyone. Like these online celebrations, nothing, right?
No, sir.
No, sir.
Okay. Okay. Then we'll have a morning session itself. I'll announce the time before 8:30. Please tell me.
Sir, like if morning, what time will it be, sir?
9 to 10, I might say. Maybe around 10 o'clock. 10:30.
Sir, morning I have a match.
Okay. Tomorrow, I'll see if you can look at the video, because I don't want to. I have some work in the evening. That is the reason.
Okay, sir. Sir, can you confirm the timing?
I'll confirm after this thing only. I can confirm, because I have to decide for 12th also.
Okay, sir.
I have other processes. Yeah. Okay. I'll see you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.